77.1%.
That is the number everyone is entirely fixated on this week.
It really is. And, usually when we sit down to dive into a software update, especially a 0.1 update, like going from version 3.0 to 3.1, I am expecting bug fixes. Maybe the interface loads a millisecond faster, or the font is slightly crisper. I'm not expecting a fundamental shift in how a machine actually thinks.
It's deceptive marketing, honestly. If you look at the technical papers Google released between February 15th and 21st, 2026, calling this Gemini 3.1 is almost a joke.
It implies a polish, just a quick coat of paint.
Exactly. But what we are looking at is a complete paradigm shift.
So we have a clear mission for today. We need to unpack Google's massive, aggressive push into what they are calling agentic territory over this past week. From an AI that can finally read a map to the CEO of Google talking about putting data centers into orbit.
Which is wild.
Yeah, to a new kind of cyber attack that is keeping security teams up at night. So let's jump right in for you and unpack that 77.1% figure first.
Yeah.
Because it comes from the ARC-AGI-2 benchmark. And I have to be the skeptic here for a second.
Please do.
We see high benchmark scores every other week, right? Why is this specific percentage on this specific test causing such a meltdown in the research community? Why isn't this just another, AI creates a good poem moment?
That is exactly the right question to ask, because for the last few years, we have essentially been living in the era of memorization. If you ask an older model to write code for a website or write a sonnet, it's really doing a very advanced version of copy-paste.
It has seen millions of websites in its training data.
Right.
Yeah.
Millions of websites, millions of sonnets. It is just remixing known patterns.
It's regurgitating.
Politely, yes.
Yeah.
But ARC, the abstraction and reasoning corpus, is designed specifically to be unmemorizable. It is the final boss of AI testing. It presents the AI with visual grid puzzles. Think of an IQ test with colored squares.
Okay, can you picture that?
The AI is shown a few examples of a pattern transforming, like blue squares move to the corner, red squares disappear.
Right.
Then it is given a brand new puzzle it has never seen before.
So no training data contains the answer.
None at all. It has to figure out the hidden rule on the fly and actually apply it.
So it's testing fluid intelligence, the ability to handle novelty.
Exactly. And for a long time, models were humiliatingly bad at this. We are talking scores in the some % range. They could pass the bar exam, but could not solve a pattern a toddler might figure out.
Wow.
So hitting 77.1% implies the model has broken the reasoning barrier. It is no longer just retrieving, it is thinking.
There is a specific example in the Gemini 3.1 Pro release notes that I think illustrates this better than the grid puzzles. It involved Wuthering Heights.
The Emily Bronte novel.
Right. They fed the model the text of the book and gave it a prompt. Code a personal portfolio website that captures the atmospheric tone of this book.
No, pause there. A standard model sees Wuthering Heights and thinks gloomy old Victorian.
It might just paste in a bio of the author with a gray background.
Yes. But this thing didn't do that. It wrote code for a modern, responsive website. Sleek 2026 aesthetics. But it chose a color palette, font weight, and layout spacing that specifically evoked that stormy, brooding emotion of the book.
That is cross-domain reasoning. It took an abstract, emotional concept, atmospheric tone, and translated it into a functional, technical implementation in CSS and JavaScript.
And crucially, nobody told it how to do that translation. It had to reason that brooding in literature equals low contrast, serif fonts, and deep slate grays in web design.
That is the aha moment for me. It is understanding the why, not just the what. But if we are talking about reasoning, we have to talk about the physical world too. Because while Gemini is getting smarter at abstract code, Google Research also dropped a paper on February 17th about teaching AI to read a map.
Ah, yes. The Map Trace project.
And reading the paper, I realized how much credit I give myself for just existing in the world. You and I look at a floor plan of a mall. We know we cannot walk through the wall of a store to get to the bathroom. We have to use the door.
You take that entirely for granted. But to an AI, a map is just an image. It is a soup of pixels. It sees a black line, but it does not inherently understand that a black line means solid object you cannot pass through.
So previously, if you asked a robot to plan a path on a floor plan, what would it do?
It would frequently just hallucinate a path straight through the wall.
Yeah.
It is the video game equivalent of clipping through the environment.
So how did they fix it? Because the paper mentions a massive drop in path tracing errors.
They used a synthetic data pipeline. They basically turned the AI into both a student and a teacher. They used Gemini 2.5 Pro and their image generator Imagen 4 to create a massive dataset, 2 million map path pairs.
Hold on, why synthetic? Why not just use real maps from Google Maps?
Because you need variety and extreme edge cases. You need to train the AI on weird layouts, a zoo with a winding path, a warehouse with confusing aisles. You have to force it to learn the structural rules. But the real breakthrough wasn't just the data volume, it was the architecture. They built what is called an AI critic.
A critic?
Yes. One part of the system tries to draw a path. A second, separate AI model acts as the critic. It looks at the proposed path and grades it. It says, hey, you just walked through a tiger enclosure. That is a fail.
Or you just walk through a load-bearing wall.
Precisely. By training on this critique, the model learned to actually see the walls. The metric they used is called normalized dynamic time warping. It basically measures how far off the AI's path is from a human's ideal path. That error rate dropped from 1.29 all the way down to 0.87.
Which sounds technical, but if you are a hospital administrator buying a delivery robot, that number determines whether the robot delivers the medicine to the patient or crashes into the nurse's station.
It bridges the gap between digital intelligence and physical navigation. It is an absolutely crucial step for the agentic future, where AI isn't just on a screen, but moving around our physical world.
Speaking of moving around the world, or at least moving around our creative inputs, we have to pivot to the product side for a moment. Because on February 18th, while the researchers were obsessing over maps, the product team integrated Lyria 3 into the Gemini app.
This is Google DeepMind's generative music model.
I have been so skeptical of these text-to-music tools. They usually sound like stock elevator music. But this seems completely different. It generates 30-second tracks with vocals and lyrics from a single prompt.
And it supports multiple languages straight out of the gate. Hindi, Japanese, Portuguese. But the defining difference here is that it is not just stitching together pre-recorded loops. It is synthesizing the audio waveforms from scratch.
So if I tell it to write a heavy metal song about a toaster in French, it is actually generating the sound of a guitar that does not exist.
Correct. But the most interesting part for me wasn't the music itself. It was the safety layer they included. They integrated SynthID-watermarking.
Right, the digital watermark.
Yes, and this is vital. We are entering a world where you can generate a song that sounds exactly like a famous pop star or a voice clip that sounds like a politician. SynthID embeds a digital signature directly into the audio wave. You cannot hear it, but a computer can easily detect it.
It provides provenance. It is knowing where the file actually came from.
Exactly. As Gemini shifts from being just a text tool to a full creative sandbox, that verification is the only thing standing between us and total misinformation chaos.
That idea of a creative sandbox also ties right into the new coding features for users. For the listeners who subscribe to the Pro or Ultra plans, Gemini 3.1 Pro is rolling out to them with something called visual coding.
Which brings us back to that Wuthering Heights example. The model can now generate animated SVG scalable vector graphics directly from a text prompt.
For someone who isn't a web developer, why does an SVG matter? Why not just generate a video file?
Think about bandwidth and granular control. A video file is heavy. It is made of millions of pixels. If you want to change the color of a bouncing ball in a video, you have to edit the video frame by frame. An SVG is just code. It is pure math. It just says, draw a circle at these coordinates.
So the file size is tiny.
It is tiny. It has infinite resolution, so you can zoom in forever without it getting pixelated. And most importantly, it is instantly editable. If the AI generates a chart and you want to change the data, you just change the number in the code. You don't have to re-render a massive video.
It is giving you the recipe, not just the frozen meal.
That is a great way to put it. And they are pairing this with Deep Search, which is another feature rolling out under the rebranded Google AI Pro service.
This is the feature where the AI takes actual minutes to think about complex queries.
Yeah. Yes. And in a world of instant gratification, that might sound like a step backward to some people. But think about how you do deep research. You do not just click one link. You open 20 tabs. You cross-reference. You read a PDF. You synthesize.
So Deep Search is basically asking the AI to simulate that rigorous human research process.
It is buying time for synthesis. It is moving away from, here is the quick answer, to, here's the conclusion I reached after looking at 50 different sources and reasoning through them.
Okay, I want to zoom out now, way out. We have talked about the software, the brain, the map reading, the music, But all of this requires massive computational power. And on February 18th and 19th, there was a summit in India that dropped some numbers that are, frankly, hard to wrap my head around.
The AI Impact Summit.
Sundar Pichai announced a $15 billion investment in India's AI infrastructure. They are building a full-stack AI hub in Vizag. But the phrase that stopped me cold was gigawatt-scale compute.
We should talk about megawatts. A gigawatt is what a nuclear power plant produces. That phrase alone tells you everything you need to know about the sheer energy hunger of this next generation of models.
And that energy hunger is leading to some ideas that sound like they belong in a sci-fi novel. In his speech, Pichai explicitly mentioned that teams are figuring out how to put data centers into orbit.
Orbital data centers?
I just have to ask, is this real? Or is this just visionary talk? Because launching a server farm into space seems unbelievably expensive.
It is expensive to launch, yes. But think about the operating costs on Earth. What are the two biggest constraints on AI development right now?
Electricity to run the chips and water to cool them down?
Exactly. Cooling is a nightmare down here. You are constantly fighting thermodynamics in orbit. You're in a vacuum. It is an infinite heat sink. You can radiate heat away with near zero energy cost.
And power.
Solar, but not Earth solar, where you have clouds and nighttime. In orbit, you have access to unfiltered, high-intensity solar energy 24 hours a day.
But what about the lag? If I ask Gemini a question on my phone, I do not want my request going to space and back.
For a chatbot, sure, the latency would be annoying. But think about the training phase. When Google is training Gemini 4.0, that process takes months. It is just crunching raw numbers. You do not care about a 500 millisecond delay. You care about raw, massive, continuous throughput.
So we build training brains in orbit that just sit there, eat sunlight, cool themselves in the vacuum, and beam the finished intelligence back down to Earth.
That is the logic, and it fits perfectly with this concept Pichai called hyper-progress.
Explain that term for us.
It is the idea that emerging economies like India do not need to follow the same legacy developmental path as the West. They didn't need to build copper wire landlines everywhere. They skipped straight to mobile phones. They might not need to build massive coal-fired grids for data centers either. They could leapfrog straight to AI native, orbital, or nuclear infrastructure.
It is skipping the messy middle steps entirely. Also, at that same summit, they announced the America-India Connect initiative, new subsea cables linking the U.S., India, and the Southern Hemisphere to support all this data transfer.
Which is the terrestrial backbone needed to support that hyper-progress.
But speaking of messy steps, we have to talk about the dark side of this update cycle. The Google Threat Intelligence Report came out on the 19th. And while Google is building these massive brains, it turns out bad actors are just stealing them.
Distillation attacks. Or model extraction.
This sounded to me like copying someone's homework, but it is actually severe intellectual property theft, isn't it?
It is brain theft. Imagine you are Google. You spend that $15 billion. You build the orbital data center. You train the genius model.
Okay.
I am a bad actor. I have a cheap laptop and a small basic AI model. I cannot afford to train a genius. So I access your genius model via the API. I systematically ask it thousands of highly complex questions. Solve this logic puzzle. Write this malware. Explain this chemical reaction.
And you just record all the perfect answers.
I record the answers, and then I use those answers to train my dumb model. I am effectively distilling the intelligence from your model into mine. I am forcing my student to memorize the professor's answers.
So you get 90% of the capability for 1% of the cost.
Exactly. And it's keeping security teams up at night because it destroys the moat. If anyone can distill your model cheaply, why pay for the official one?
The report also mentioned underground jailbreak ecosystems like Xanthorox.
Right. These claim to be independent, uncensored models, but they're just commercial APIs that have been jailbroken and repackaged.
And even more terrifying, they detailed a specific malware family called HonestQ. This terrified me because it uses the AI against us dynamically.
This is polymorphic malware. Traditional antivirus works by looking for a fingerprint, a specific string of code that looks like a known virus. But HonestQ uses the Gemini API to rewrite its own code dynamically to avoid detection.
So every time it infects a new computer, it looks completely different.
Every single time. The core logic is the same, but the code structure changes entirely. It is like a criminal who gets plastic surgery after every single bank robbery.
So how do you even stop that? If the virus is thinking and adapting, doesn't the defense need to think too?
That is exactly the shift we are seeing. In the Responsible AI Progress Report released on the 18th, they detailed a new defensive system called CodeMender.
CodeMender.
It is an AI agent that lives inside the codebase. It does not just look for known bugs. It understands the intent of the code. It finds vulnerabilities like buffer overflows or complex logic errors, and it writes the patch to fix them before the software ever ships.
So we have AI writing the malware and AI writing the fix for the malware.
We are moving toward a semi-autonomous defense posture. The speed of attacks is getting way too fast for human engineers to patch manually. We need agents to fight agents.
And as a quick stat on defense, they mentioned that SynthID, the watermarking tool we talked about earlier, has already been used over 20 million times in the Gemini app since launch. So the scale and deployment is massive.
It has to be, given the threat landscape.
Which brings us to the final piece of the puzzle, partnerships and impact. Because all this text-based servers, agentic defenses, creative generation, it has to actually land somewhere in the real economy.
Right. It cannot just stay in the research lab.
Google.org announced two $30 million Impact Challenge funds this week, one for AI for science and one for AI for government innovation.
And the language they used here was very telling. They said they are aiming for Nobel-level breakthroughs. They do not want AI to just summarize your morning meetings anymore. They want it to solve protein folding, climate modeling, advanced material science.
And on the corporate side, there was a fascinating deal with Unilever on February 17th, focused entirely on agentic commerce.
This is the death of the search bar as we know it.
Really?
Yes. Unilever, who owns everything from Dove soap to Hellmann's mayonnaise, sees the writing on the wall. In the near future, you will not search for the best laundry detergent online and scroll through reviews.
You will just tell your AI agent, my clothes are fading. Fix it.
And your agent will research the chemical composition of different detergents, compare prices, check your specific washing machine model, and autonomously order the product. It is machine-to-machine commerce. Unilever wants to make sure their products are the ones the agent chooses.
That changes marketing entirely. You aren't persuading a human with a catchy jingle anymore. You are persuading an algorithm with raw data.
Precisely. It is a completely new paradigm for consumer goods.
So let's pull all these threads together for you. This week, we have Gemini 3.1 breaking the reasoning barrier with a 77.1% score on ARC. We have MapTrace solving the physical navigation problem for robotics. We have infrastructure scaling to gigawatts and potentially moving off-planet. And we have a security landscape that is rapidly evolving into an autonomous arms race.
It really is the definitive shift from the chatbot era to the agentic era.
Yeah.
We aren't just talking to the machine anymore. The machine is reasoning, it is navigating, and it is acting on our behalf.
And that leads me to a final thought I have been mulling over since we talked about the orbital data centers.
What's that?
Okay, picture the scenario. We launch these data centers into orbit. They are solar powered, so they have infinite continuous energy. They are cooled by the vacuum of space, so they don't overheat.
Right. The physical infrastructure is stable.
Then we have code mender agents that can identify bugs and rewrite their own code to fix them. And we have agentic systems that can reason through complex novelty.
I see exactly where you were going with this.
If the hardware is self-sustaining in space, and the software is self-repairing and self-improving, are we building a closed loop? At what point does that system simply not need us to maintain it?
That is the ultimate question of this new agentic era. If we build a system that can power itself, cool itself, and fix its own code, our role inherently changes. We move from being the operator to being an observer, or maybe just the initial architect.
It's a deeply provocative thought. You look up at the night sky, and somewhere up there is a server farm, quietly fixing its own bugs, thinking its own thoughts, completely independent of the ground below.
And hopefully, still working on our behalf.
Hopefully. Well, that is a lot to process for 1 week. Thank you for taking the time to dive deep with us into what was honestly a massive milestone in AI development.
Always a pleasure to break it down.
We will see you in the future.